lesson we are going to be doing quadratic word problems using our graphing calculator. So you'll need your calculator for this. In the first problem it says a boat in distress twice, they're in so much distress the word is written twice, launches a flare straight up with a velocity of 190 feet per second. The height of the flare in feet can be modeled by the following equation. They want to know what the maximum height of the flare is. So we could do this by hand, but we're choosing to use our calculator for this. So when you look at your calculator, I'm going to go into y equals, and I'm going to put that equation in there that they just gave me. So I'll do 190x minus 16x squared. Now when I hit graph here, I'm going to do, if your graph looks weird, just hit zoom 6. It should be a normal graph then. Here's my graph. I can't see anything. Can you see anything? I should be able to see something, so let's make sure I put this in right. Ignore what I'm doing. Nothing is showing up in my graph, so I'm thinking I need to zoom out, right, to look at this. So I'm just going to hit zoom 3, enter. Oh, there's a picture. Okay. Now, my parabola is not even close to looking like a parabola right now, is it? So I could keep zooming out and zooming in, but that would be utter chaos. So what I'm going to do is I'm going to try and change my window to fit this graph. So it looks to me like my parabola is starting over here, and it maybe will go like this. I'm not really sure, but I'm going to say that I'm going to keep my x values from 0 to like 10 to start. And I think it goes pretty high. So I'm going to pick my y values maximum to be like 200. I'm just making up a number. And then I don't know how low I want to go here because I know my parabola goes up. So I'm just going to go like to negative 50 on the y. In order for me to do that, I'm going to erase this so you can see it. I go to my window. And I'm going to say, okay, my x minimum, I said, did I say 0, I think? And then we said 20. X max is 20. And then we're going to go down. And my y minimum, I think I said negative 50. And then I want it to go to 200. And I'm going to see if my parabola now shows up. So when you hit graph, oh, much better. I think I went too far on my x's, though. I want to shift it left a little bit. And obviously I have to go much higher with my y values, right? So let's go back to our window. I'm going to say, how about negative 10? And even, I think I could have gone, let's just leave it at 20 for now and see what that looks like. And that was okay. My y maximum, I want to go higher. Let's just try like 500. I don't really know how high I need to go, but let's hit graph. Oh, I almost got the whole parabola in there. See that? I'm almost to the top of the parabola. I need to go higher with my y's. So when I go to my window, let's just go like 600. See what that looks like. Hit graph. Oh, there's my parabola. So that's a pretty decent picture. They asked for the maximum height, so I can kind of move my cursor and I could try to find that, but that's not going to give me the exact height. In order to get the exact height, I have to hit second trace or second calculate. So second trace button, which is calculate. I want to calculate the maximum, so that's number 4. Remember we did this before? It says left bound, so I go to the left of the hill, and then I go over the hill for the right bound. Hit enter, and then for the guess I go right on the hill, hit enter, and the maximum value would be my y value. So my maximum value is 564.06 feet. So if I go back to my problem, for letter A, the maximum height is, I'll say max height is approximately, because I'm rounding, 564.06 feet. It says how many seconds after the flare was shot was it at its maximum height. So here they're asking for my x value, and you can see that at the bottom of my screen here. That's my x value. So I can say that let's go back here, how many seconds after, it would be, x would be approximately 5.94 seconds after. Then the last question for this problem says, ignoring the height of the boat, how many seconds how many seconds will it take for the flare to hit the water? So they want us to assume the boat starts at 0 because we don't know about the height of the boat. So I'm looking for when it hits the water. When it hits the water, the distance would be 0, right? So I'm going to plug that in. I want to find h of t equals 0. Now I could do that by hand, but I'm going to use my calculator because I want to find the 0. So I go to second, calc again, and this time I'm looking for the 0. So it'll have me go left of the 0. Now, my 0 is occurring somewhere down more, right? So maybe I need to go this way. Let's see how far down it shows me, because I thought I was under the axis. Here, I'm going to change my window for a second and make my y value go a little bit lower. Negative 100, how about? Hit that graph. Can I see the 0 now? Okay, there it is. See it right here? I'm looking for this right there. That's what I'm looking for. So now I'm going to go second, calculate. I'm going to pick the 0. And now the left bound, I'm going to go all the way until I get almost to that point where it crosses the x-axis, but not quite. That's too close maybe. I'll go right there, hit enter. And then I'm going to actually cross the x-axis and hit enter. And then my guess, I'm going to try and put the point right on the axis. That's about as close as I can go. And I get 11.88. So my 0 happens at 11.88, excuse me. So ignoring the height, I would say at approximately 11.88 seconds. That's how long it takes the flare to hit the water. So that's how I would use my calculator for those. So we'll try a couple more. This one says NASA's KC-135A aircraft flies in parabolic arcs, is that a fancy word, to simulate the weightlessness experienced by astronauts in space. The height h of the aircraft in feet t seconds after it begins its parabolic flight can be modeled by this following equation. What is the maximum height of the aircraft during this maneuver, and when does it occur? So, again, I'm going to put this in my calculator. Y equals, and I'm going to punch in negative 9.09 x squared plus 590.85x and then plus 24,398.6875. And then when I hit, I'm going to go back to my normal window. So if I had zoom 6, that takes me back to my 10 by 10 window. And again, I do not see anything. Here's a hint though. If you look at my table, see where x's are here? Look at what the y values are. They're in the 20,000s. So I definitely need to move my y values up. So I'm going to start with, let's say, my x value is going from like negative 10 to 10. I don't even know what it should be, but negative. We'll keep those there. Let's move my y value. My minimum, let's just do like negative 50. And then that maximum, since it was in the thousands, I saw some values at 20,000. I'm going to pick like 40,000. I'll double it just to see what it looks like. I'm not sure if this is going to be good or not. Oh, okay. That looks like part of my parabola, right? But I definitely need more x values. So when I look at my window, I'm going to change my x values to be like negative 100, 100. And then 100. Let's see what that looks like. Can I see? Oh, there we go. I see a parabola. I don't really like that I can't see where it crosses the ground, so I'm actually going to, I think on the left side, negative 100 is too far. So I'm going to go like negative 50. Can we try that? See what that looks like. See, it's a quick fix. That's a little better. And now I want to go a little lower with my y values. So my y minimum, let's do like negative, I don't know, negative 100. Let's try that and see what that looks like. Oh, I'd even like to go lower, I think. Let's try negative 200. I mean, the y maximum is 40,000, so. A little better. I'm going to actually, well, I'm going to leave it here. I think that's pretty good. I can see most of my parabola. So now, when I look at this, I'm going to look for what it asks first is the maximum height. So again, I go to second, calc, and I'm doing maximum. And then it's going to ask me to go left bound, which is pretty much on the left bound right there. So I'm going to hit enter. Then I'm going to go over the hill, hit enter. And then for my guess, I'll go right on top of the hill, hit enter. And it tells me that my maximum is 34,000. So 34,000. And it says, when does it occur? Well, that's the x value. So it occurs at 32.5 seconds. So for my notes, I will say max height is 34,000 feet at 32.5 seconds. Now, this is, if I was thinking of my vertex for my parabola, this is my vertex right here. So that's what they are really asking for. And then the last question says, if it is only safe for the astronauts to have a 45-second free fall, so that's weightlessness for 45 seconds, how high will the aircraft be when they have to turn the engines back on? So, at its maximum height, the aircraft has been in the air for 32.5 seconds. So I know that it's at maximum height, it's 32.5 seconds. And they said it's only safe to be weightless for 45 seconds. So I've already gone 32.5 to get to the max. Then I have 45 seconds before it's unsafe to be weightless. So I'm really looking for 77.5 seconds. That's what I'm trying to find. In order to do that, I can actually plug that into my calculator and it'll give it to me. So I go here, and to find out where it is at 77.5 seconds, I do second calc again. And I'm actually looking for a value here. So when I hit enter, it says x equals, and I'm going to say 77.5. Tell me what the y value is after 77.5 seconds. And then I hit enter, and there's the y value, 15,592.75. So, if I go back here, I would say the spacecraft will be at a height of 15,592.75 feet when the engines get turned back on. Think about what they're saying they're doing here. When they fly up, they stop at this height and then they turn the engines off. So the plane goes whoop. I mean, think of how fast that is, and that's how they experience that weightlessness. That's what they're trying to mimic. So they can feel what that's like. A lot of people would probably want to do that for fun. Alright, so there's our question there. Now, number 3, our last one. It says the height of a punted football can be modeled by the function listed there, where the height of the ball, h of x, is given in meters, and the time x is given in seconds. So, what is the maximum height of the football? So here is, you can see the punting, and they have a little bit of a graph and all kinds of crazy stuff written down there, right? So the maximum height, again, we would look at on our calculator. So I'm going to go to my calculator, I'm going to go to y equals, and I'm going to type in my new equation, which is negative 4.9x squared plus 20x plus 1. And I'm going to go ahead and hit zoom 6 to graph it in my normal graph so my windows change back. And I almost have that parabola on there, don't I? I think my x values could be less, and I need to go higher with my y values, don't I? So I'm going to go to my window, and I'm going to do my x minimum maybe at negative 5. And I actually think my x maximum could be, well, we'll leave it where it is for now, I guess. I could maybe go to 5. And I'm going to keep my y minimum negative 10. I think that seemed okay. And my height, let's go to like 30. I'm just picking a number. And I hit graph. There we go, I can see it. Now if I want to see a better picture of this, I could always move my x values back, I could move my y's down, however you want that to look. Your window doesn't have to be the same as mine. As long as you can see the top, you're fine. So again, I go second calculate, and I'm going to calculate the maximum height. So I hit enter, move to the left of that graph, left bound is right there. I go right bound, right here, and then the top, right there. And my maximum height is 21.41. And then that happens at, so I get y equals 21.41 meters. I was trying to see what the label is, meters. So they asked me, what is the maximum height of the football? And I'm going to say max height is approximately 21.41 meters. Now, at what time in its flight is the football within 5 meters of the ground? 5 meters of the ground. If it's within 5 meters, I'm looking for it to be, my height, to be less than or equal to 5. So really, I'm going to plug that 5 in to my original equation for that height. So I'd say 5 equals negative 4.9x squared plus 20x plus 1. Which is hard to think about. That's kind of confusing to think of that, but that's what they want me to do. And so now I want to find where that, when I plug the 5 in, where that graph would be at the zeros, where my graph would cross the x-axis. So I minus 5 from both sides here, and here's my new equation I'm going to put in my calculator. So I go to my calculator, and I'm going to change my equation to be the same, except instead of the plus 1, I have a minus 4. There we go. Oops. Minus 4. Now let's see if that graph looks okay. Can I still see it? I can. So I'm looking for the zeros. I'm looking for these 2 points right here. So I'm going to find both of them one at a time. So I go second, calc 0, hit enter. I'm going to go left bound, so right there, go over the axis, right there, go on the axis, and my first 0 is 0.21. So my first answer, so within 5 feet, is 0.21. I'm going to write this a little more eloquently after I get my answers. And then the second one, I do the same thing. Second, calculate 0. And I'm going to move this way. I'm going to hit enter. I'm going to go over, hit enter, try to go right on, and I get 3.87. Just a reminder, when you see this right here, that's in scientific notation, so that number is very close to 0. I don't know if you remember that from when we first learned this. So 3.87. So I go back to my notes. My other number was 3.87. So I would say, because I want to kind of write it a little bit more in sentence form, I'm going to say the ball will be within the first 5 meters of the ground, the first 0.21 seconds, and after 3.87 seconds. So the first 0.21 seconds, it's going to be within 5 meters, and then it's above 5 meters. And then it's coming back down, and after 3.87 seconds until it hits the ground, that's where it's below 5 meters. That's what we just found. Let me know if you have any questions on that tomorrow. We can go through it in class.